So here's our first example. Suppose that we have this system of right triangles, as we've discussed so far, and the short side of the hypotenuse is 3, and the long part of the hypotenuse is 5. The altitude is h. Let's say that this leg of the large right triangle is x, and the other leg of the large right triangle is y. So we're going to use our schematic diagrams to solve for the missing sides, and those missing sides are x, y, and h. So let's use the first schematic. It's going to look like this. And I'm not very good at drawing these, but I think you get the idea. Okay, so the first part of the schematic is the short part of the hypotenuse, which is 3, and then the altitude, and then the altitude again, and then the long part of the hypotenuse. And so this allows us to write the proportion 3 over h is equal to h over 5. And cross-multiplying that proportion, we end up with h squared. Let me try that one again. And we have h squared is equal to 15. Taking the square root of both sides of the equation, we get h is equal to the square root of 15. So we were able to use the first schematic diagram, the one that started in the left corner of the hypotenuse, and we were able to use that to figure out what the altitude of the large right triangle is. And so the end result of that first part using the first schematic diagram was that the height h is equal to the square root of 15. So now let's move on to using the second schematic. The second schematic, I'm going to try to use a straight line tool here. The second schematic starts again at the left corner of the hypotenuse. It incorporates the entire hypotenuse. Then it goes up along the leg of the right triangle, and then back down along that same leg, and then back to incorporating the large part of the hypotenuse. Okay, and so now the entire hypotenuse, again, starts on the left side over here and goes all the way across. We see it's made up of two parts. One part is 3, the other part is 5, so if we add both of those together, we get 8. So the first part of the hypotenuse is 8, and then we turn from there and we go up the leg of the triangle, which is x. We come down that same leg, which again is x, and then we go back along the long part of the hypotenuse, which is 5. And so that allows us to write the proportion 8 over x is equal to x over 5. Let me try that 5 again. That's kind of ugly. Yeah, that's a little better. Okay, so then cross-multiplying, we get x squared is equal to 8 times 5. But 8 times 5 is the same as 4 times 2 times 5. I'm not sure I'm going to be able to squeeze in that last part there. 4 times 2 times 5. Okay, and then if we take the square root of that, okay, we get the square root of x squared is x, and the square root of 4 is 2. The remaining part there is 2 times 5, which is 10, and so we just take the square root of 10. And so having used the second schematic diagram, we were able to fairly quickly figure out that the long leg of the large right triangle is 2 root 10. So let's put that result over here on the left side. So we got x was equal to 2 root 10. Okay, so now it's time to use the third schematic diagram. This one we're going to start over in the lower right-hand corner. And just like the last one, the third schematic involves the entire hypotenuse, and then it goes up along the shorter leg of the large right triangle, and then back down along that same leg, and then along the shorter part of the hypotenuse, like that. Okay, so again, the entire hypotenuse was 5 plus 3 in this case, which is 8. Okay, the short leg of the large right triangle is y. And then we come back down along that same side of the triangle, so we have y again, and then the short part of the hypotenuse is 3. So this allows us to write the proportion 8 over y is equal to y over 3. Cross multiplying, we get y squared is equal to 8 times 3, which is 24, and that's the same thing as 4 times 6. Now, I'm doing that, writing it that way, rather than writing it as 8 times 3, I'm writing it as 4 times 6. It's the same thing, but I'm doing that because 4 is a perfect square, and when we take the square root of both sides of this equation, we want to extract the highest perfect square that it's possible to extract. And so in this case, that would be the number 4. So now we take the square root and we get y equals, and the square root of 4 is 2, and we get the square root of 6. Okay, so there we've used the third schematic diagram to figure out what that missing side y was. So again, the 3 schematic diagrams, let's review what those were. First, let's put our result for y over here. We had y equals 2 root 6. There we go. Okay, so we have the 3 missing sides of the triangle. And then just to review our 3 schematic diagrams, the first one looked like this. It was the short part of the hypotenuse, the altitude of the large right triangle, and again the altitude of the large right triangle, and then the long part of the hypotenuse. That allowed us to write the proportion 3 over h is equal to h over 5. The second schematic diagram started on the far left of the right triangle, went all the way across the hypotenuse, then up the long leg, put that over here, then back down that same leg, and then over to the long part. That allowed us to write the proportion 8 over x is equal to x over 5. And then the third schematic started over on the right side of the triangle, went all the way across the hypotenuse, up the short side, or rather the short leg of the large right triangle, back down that same leg, and then back on the short part of the hypotenuse of the large right triangle. That allowed us to write the proportion 8 over y is equal to y over 3. And so using those 3 schematic diagrams allows us to solve for the missing sides of the right triangle, and thereby makes our lives much easier. That's a lot easier than redrawing all 3 of the embedded right triangles there and trying to figure out which proportions go with which. This will give you the right answer every single time.